Today we're going to start chapter 3.4, which is adding and subtracting radicals. In your notes, chapter 3, we're on page 4. So first of all, in order to add or subtract radicals, the radicals must be like. What that means is their radicands must be equal to each other. So I'll just say equal radicands for radicals to be alike. So what you're going to do is just add or subtract, which means combine the coefficients, and just carry along the radical or the radicand. What I mean by this is these two radicals are alike because they both have 2's as radicands. So 3 square root of 2 plus 5 square root of 2, it's almost like 3x plus 5x, which would be 8x, but that's 8 square root of 2. And number 2, the radicals are alike because the radicands are 3, so this is almost like 7x minus 5x, and 7x minus 5x would be 2x, but it's 2 square root of 3. In this one, you can't add those together because this is a 50 and that's a 2. So what you have to do is you have to simplify this square root of 50. So we're going to break 50 up into 25 times 2. 25 is a perfect square, so you're going to circle it, and you're going to bring it outside, so this is 5, and what stays underneath? The square root of 2. So the square root of 50 is really the same thing as 5 square root of 2, and then you're going to tack on plus the square root of 2. It's just like 5x plus x, and 5x plus x is 6x, 6 square root of 2. There's an invisible 1 coefficient. Here's one where you have to subtract and add. The square root of 12, well, 12 breaks down into the square root of 4 times 3. You're going to circle the 4 because you're going to take the square root of 4 and bring it out and call it 2. So this is 2 times 3, and what stays underneath? The square root of 3. Now the square root of 4 is a perfect square. The square root of 4 is just the number 2 without a square root. And then 5 square root of 3 stays 5 square root of 3. So what does this turn into? Well, you're multiplying these two coefficients. 2 times 3 is 6. And the square root of 3 stays underneath. So 3 square root of 12 is equal to 6 square root of 3. And then you subtract from that the square root of 4, which is 2. Whoops, I wrote a 5 there. It should have been a 3. And then over here, you're going to add to that 5 square root of 3. And we have two parts that are like. This is like 6x plus 5x, which is 11x. So we can call that 11 square root of 3 minus 2. And you can't combine those together because that 2 doesn't have a radical on it. Square root of 8 can be broken down. So this is 4 times 2, which is 8. The square root of 4 is 2. So we're going to bring that outside and call that 2 times 3 square root of 2. So 2 times 3 is 6, and then the square root of 2 is written again. And this is like 6x minus x. 6x minus x is 5x, so 6 square root of 2 minus the square root of 2 is 5 square root of 2. And then the last problem, you have a couple of them that can be simplified. We've already done the square root of 8 before. This breaks down into 4 times 2, which we're going to take the square root of 4 and bring it outside and call it 2. The square root of 18 breaks into 9 times 2. We're going to take the square root of 9 and call it 3. So this is 2 times 5, and this is going to be 3 times 3. And then the square root of 3 is just brought along down here. So we have 2 times 5, which is 10. The square root of 2 stayed the square root of 2. The 3 moves outside. 3 times 3 is 9, square root of 2. And then we have the square root of 3. You can't combine the square root of 2 with the square root of 3 because they're not alike and they can't be broken down either. So what we're going to do is this is like 10x minus 9x, which is just x. So 10 square root of 2 minus 9 square root of 2 is just a square root of 2 plus a square root of 3. and you cannot combine them. That's like trying to add x plus y. You can't do that, so you can't combine. And then I have a list of problems down here. These just came out of our textbook, so I'm just going to select some of these problems to do. The first one is the square root of number 11 I'm going to do. So the square root of 24. Well, the square root of 24, the biggest perfect square in 24 is 4. 4 times 6 is 24. The x stays an x, and the y squared stays a y squared. So that's your first one. And the second one, 54, the biggest perfect square in 54 is 9. 9 times 6 is 54. And then the x stays an x, and the y squared stays a y squared. You're going to circle all the perfect squares. Circle the 4 and circle the y squared. They're the ones that are going to come out. Circle the 9 and circle the y squared. Square root of 9 is 3. The square root of y squared is y, and they're going to come out. So now on the next line over, we're going to bring the square root of 4 out and call it 2. The square root of y squared, and bring it out the y on the outside. And then we have a 6x that we didn't circle. That stays underneath. The square root of 9 is 3. The square root of y squared is y. And then we have 6x that we didn't circle. And so now we can add, because these are like radicals. The 6x's are equal to each other. So this is like 2y times something plus 3y times something is 5y. 2y plus 3y is 5y. And what's the radical? The square root of 6x. So that's the final answer on that one. The next one is number 13, 98. Well, that's a pretty big number. 98 has a perfect square of 49. It's 49 times 2 is 98. C to the 5th is not a perfect square, so I'm going to break that up into the c to the 4th times c to the 1st. So that's the first one. Subtract from that the square root of 18. Well, 18 is just 9 times 2. And c to the 5th, again, is going to be brought out into c to the 4th times c. So there's the first step. Second step is we're going to circle all the perfect squares. 49 is a perfect square. He's coming out. C to the 4th is a perfect square and it's coming out. 9 is going to come out and become a 3. C to the 4th is going to come out and become a c squared. So what we have next, I'm going to write underneath here because I'm not going to do question 15. The square root of 49 is 7. The square root of c to the 4th is c squared. And what we didn't circle was the 2 and the c. And here the square root of 9 is 3. The square root of c to the 4th is c squared. And what we didn't circle was a 2 and a c. So now we have 7c squared something minus 3c squared something. Those are like radicands. So 7c squared minus 3c squared is 4c squared. And then we bring along the radical 2c. The next one I'm going to do is question 23. Question 23, this first radical can't be simplified because 3 can't break down and neither can y. This can't be simplified because the same situation is happening. But this one, 36 is a perfect square, so I'm just going to circle him. And y to the 4th is a perfect square, so I'm going to circle that one. So what we can do right away is, because these two are like, this 2 square root of 3y plus 4 square root of 3y, I'm going to add those up right now. 2 plus 4 is 6. The square root of 3y just gets brought along. And now I'm going to subtract the minus 5y squared. And then I have to add to that, the square root of 36 is 6. The square root of y to the 4th is y squared. And there's no more radical because we don't have anything left that we didn't circle. And now I have like terms that I can combine. A negative 5y squared and a 6y squared is just 1y squared. So our final answer is 6 square root of 3y plus y squared. Those two combined. And you can't combine them because they're not alike. The next one I'm going to do is this cubed root. And if you forgot about the cubed root, you can go back and look. over on the previous page. And our perfect cubes, 8 and 27 and 64, they're the ones that we want to look at to see if any of those numbers will go in to this number. Well, 54 does have a perfect cube in it. 54 is 9 times 6, but neither 9 nor 6 is a perfect cube. But it's also 27 times 2. So we can break this down into its perfect cube. And it's very tempting to call this 9 times 6 because we think of the perfect squares, but remember this is a cubed root, so we're looking for a perfect cube. Perfect cube is 27. Remember 27 is on that list, but 9 isn't. It's 8 and 27 and 64. So 27 times 2 is 54. Now what else do we have? 128. Well, if we look on this list over here, which one of these numbers, oops, you can't see that, which one of these numbers on the perfect cube list goes into 128? Well, 64 does. So I'm going to write 128 is 64 times 2. Circle the perfect cubes. Cube root of 27 is 3. The cube root of 64 is 4. So they're going to come out and become 3 times the cubed root of 2 plus, remember the cubed root of 64 is 4. 4 times the cubed root of 2, what we didn't circle. And this is like 3x plus 4x, which is 7x. So it's 7 times the cubed root of 2. And be careful, make sure you write that cubed root every time. And then the last one on this page I'm going to do is number 37. So this is just a square root again. And 50 can break down into the perfect square of 25 times 2. X cubed can break down into x squared times x. 200 can break down into 100 times 2. And again, x cubed can be broken down to x squared times x. And now when we circle the perfect squares, 25 is going to move out, and x squared is going to move out. 100 is moving out, x squared is moving out. So the square root of 25 is 5, the square root of x squared is x. They stay out, and what stays in? What we didn't circle, 2 and x. The square root of 100 is 10. The square root of x squared is x. And what didn't we circle? We didn't circle the 2 and the x. And so now we can combine these because they're like. The two x's are the same. 5x plus 10x equals 15x. And then we can bring along the square root of 2x, and that's the end of that problem. Over on the other page, we're just going to multiply. We're not going to divide today. But when you multiply, it's a lot easier than adding and subtracting because all you have to do is multiply the coefficients, which are the outside numbers. Multiply the radicals, or the radicands, which are the inside numbers, and then simplify if you can. What that means is, on 1, the square root of 2 times the square root of 10, well, there's no coefficients, so we don't write a coefficient outside, and 2 times 10 is 20. So you're just going to multiply the 2 times the 10. It's so much easier than adding. And 20 can break down into 4 times 5. Circle the 4, move them out, and this becomes 2 times the square root of 5. And number 2, multiply the outsides. 3 times 5 is 15. Multiply the insides. 6 times 2 is 12, and this stays inside. But 12 can be broken down into 4 times 3. You're going to take the square root of 4 and call it 2. And this becomes 15 times 2, square root of 3, which is really just 30 square root of 3. And that's all we can do with that problem. I'm going to skip the next two because they're division, and I'll talk about those on the next video. Down here I'm going to go through some of these problems. These are all multiplication problems, but these are distribution problems. You're going to distribute the 2 square root of x into each one of these radicals through multiplication. So 2 square root of 6 times 5 square root of 2. Remember, you're going to multiply 2 times 5 and get 10. The square root of 6 times the square root of 2 is the square root of 12. 2 times 1 is 2. Remember, there's an invisible 1 out here. And 6 times 15. Let's see what 6 times 15 is. I want to make sure 15 times 6 is 90. So this is 2 times the square root of 90. And now we have to simplify that down. 12 breaks down into 4 times 3. 90 breaks down into 9 times 10. And we're going to take the square root of 4 and call it 2. Take the square root of 9 and call it 3. So we have 10 times 2 square root of 3 minus 2 times 3 square root of 10, which is 20 square root of 3 minus 6 square root of 10. You can't add those together because one's the square root of 3 and the other's the square root of 10. The second one, when you have a squared on a binomial, you have to FOIL it. You have to multiply 3 plus the square root of 2 times 3 plus the square root of 2. Remember, that's a FOIL. Don't just square each individual term. You have to FOIL this. So the FOIL gives you 3 times 3, which is 9. 3 times the square root of 2, which is 3 square root of 2, and then another 3 times the square root of 2, and the square root of 2 times the square root of 2 is the square root of 4. Well, what is the square root of 4? The square root of 4 is just 2 without a radical. So we have 2 like terms in the middle. 3 square root of 2 plus 3 square root of 2 is equal to 6 square root of 2. Plus 2, and then I'm going to drop the 9 down here. And then we have 9 plus 2, which is 11, plus 6 square root of 2. So remember, this is a FOIL, and that's just don't be fooled by that. This is another FOIL, but this is easier to see that it's a FOIL. So let's FOIL this out. 5 times 2 is 10. 2 times the square root of 6 is 2 square root of 6. 5 times the square root of 6 is 5 square root of 6. The square root of 6 times the square root of 6 is the square root of 36. So we have 10 plus 2 plus 5 is 7 square root of 6, and the square root of 36 is just 6. Remember, he's a perfect square. Now we can add 10 plus 6 is 16, and we have 7 square root of 6, which is remaining. So that's the final product of that one. This one we have to FOIL. 3 times 3 is 9. 3 times negative square root of 7 is negative 3 times the square root of 7. 3 times positive square root of 7 is 3 times the positive square root of 7. And the square root of 7 times the square root of 7 is the square root of 49, but positive times negative is negative. And you might have noticed that if you're multiplying the square root of 2 times the square root of 2, you're going to just get a 2. The square root of 6 times the square root of 6 is just 6. So these two combine to 0. So what we have is 9 minus the square root of 49 is 7. So that answer is just a 2. No radicals. On this next one, 2 times 1 is 2. 2 times the square root of 3 negative is negative 2 square root of 3. Square root of 12 times 1 is the square root of 12. 12. And positive times negative is negative. 12 times 3 is 36. 12 is going to be broken down to the square root of 4 times 3. And the square root of 36 is just 6. We're going to take the square root of 4 out here and call it 2. So what we have is 2 minus 2 square root of 3 plus 2 square root of 3 minus 6. And again, we have 2 square root of 3, negative and positive go to 0, and we have 2 minus 6, which is equal to negative 4, with no radical in the answer. Sometimes you get that happening. Not always, but sometimes. And this last problem we're going to do, We're going to FOIL this. 5 times 1 is 5. 5 times negative square root of 2 is negative 5 square root of 2. 1 times the square root of 8 is the square root of 8. The square root of 8 times the negative square root of 2 is negative 8 times 2 is 16. We're going to break 8 down into 4 times 2, and the square root of 16 is just a 4 with no radical. The square root of 4 is going to move outside and become a 2. So we have 5 minus 5 square root of 2 plus 2 square root of 2 minus 4. And then the like terms, we have negative 5. It's like negative 5x plus 2x, which is negative 3x. But we're going to call that negative 3 square root of 2. And then we have 5 minus 4, which is just 1. And you can't combine this 1 minus 3 because this has no radical and this has a radical. And that's all for today. See you tomorrow.